There we go. Adam Jimerson, everybody. Round of applause for Adam.
Thank you, everybody. So I know in the past there's been several talks on Docker and the Linux containerization engine. So I figured it'd be interesting to give a talk that shows containerization from a different perspective, where a containerization that existed before Linux even had that capabilities. This containerization is FreeBSD Jails. So a little bit about me before we get into it. I am system architect at Utiliflex. We are a software company here in town that does software for utilities, allowing them to do prepaid electricity and smart grid metering. So we talk to various meter types, and we're able to read, connect, and disconnect someone's electricity supply remotely. I'm also a developer for the PacBSD project, which is a free and open source operating system based off FreeBSD and Arch Linux. So a little bit of history about what FreeBSD is. The Berkeley software distribution was developed by the Computer Systems Research Group in Berkeley University, California, between the years of 1977 and 1995. It started off as a series of patches to Bell, at the time Bell Labs, but AT&T's sysv Unix. It was originally to add new features, fix bugs, things like that, but over time as went on, it got more involved where they even started replacing bits of the AT&T's code base. Talk about a senior project. It was the base and or inspiration for multiple operating systems, including Sun Microsystems Sun OS, NextStep, and OpenStep. Darwin, which is the base for OS X, macOS, and iOS, FreeBSD, and NetBSD. Nowadays, while Berkeley's not maintaining their stuff anymore, the term BSD is used to refer to the derivatives, so FreeBSD, OpenBSD, NetBSD, DragonflyBSD, PacBSD, and things like that. Some companies out there that use FreeBSD in one way or another, and in fact, one of these companies on here, they may or may not still, but at one time they acquired a service called Hotmail that was originally developed on FreeBSD. When they bought that, they tried porting it to their own platform, failed so epically that they rolled back to the FreeBSD servers, put one of their own servers in it to rewrite headers to make it look like it was running on a Windows server. On top of that, NASA, JPL, Juniper Networks, Dell, Sony, Y Combinator, and a bunch of others. So what is a jail? In March 14th in 2000, FreeBSD launched version 4.0, which had a thing called jails. This was built to enhance the security through process isolation. Works much like how CHROOT does, where it effectively changed where the process thought the root of the file system was to a certain point, and then prevented ways for them to escape out to the actual root and be able to manipulate files and things like that there. But jails went multiple steps farther than that. Their main goal at that time was to limit the amount of damage an attacker could do if they were to basically attack one of the jails. And it fixes limitations that's in CHROOTs through not only the process isolation and the root changes, but it also virtualizes like users, file system access, and even the entire network stack. So yeah, as I said, better isolation than your standard CHROOT environments, and that they've virtualized file system users and things like that. It also gives a finer grained control over processes within the CHROOT. You can say this jail over here has access to this device and this device only versus a bunch of others. And so when you are looking in there and you do an ls of /dev, you'd only see specific devices that you allow. And they also don't allow for changing of things like the IP table, IP routing or routing table and a bunch of other. And it's considered what's called an operating system level virtualization tool. So if you deal a lot with virtualizers, you know that there's multiple classifications of them. This one's OS level, and it's considered more lightweight than some of the other options out there. So things that make up jails, there's 4 key components. There's a directory subtree if you're using the Unix file system 2, or a ZFS dataset for the file system. Each jail has to have a unique host name. They'll have one or more IP address that can be routable or non-routable, and a command to run within it. And this command is relative to the path within the jail. So say you gave it the path /bin/true. That's the true command within the jail, not the true command on the host. And so on top of having their own set of users, they also have their own root user, which can only manipulate that jail. And there's conceptually 2 main types. There's what's called a complete jail, which mimics the full entire operating system. And then there's the service jail, which is just has enough information for 1 or 2 processes, much like how you would do a chroot. So you put the command you want to run in the chroot environment and any files it needs to access in that environment. Also, there's a few others that are defined but not actually true. There's the there's the lightweight and clones, but they're more community focused. I'll get to what that means later. So it wouldn't be a FreeBSD talk without bringing up ZFS though. So while jails can run perfectly on the UFS 2, it gets better with ZFS. One of the reasons why is because each jail can have has its own data set at that point. And then you can even go a step farther by, within the jail, defining that as your pool. Basically, if you're familiar with a software RAID, you can define your pool as your RAID at that point, and you can slice it out how you want. And then within that data set can have its own data sets. And you can get crazy with jails having their own jails with data sets. You can use ZFS snapshots to be able to back up and restore your jails. So these are very lightweight copy on write images. You'd create that, and then all data that's changed after that snapshot was created is recorded there. So when you roll back, you go back to the point that snapshot was. And then, so a little on the networking. It's typical that when you define your IP address for the jail, you will assign it as an alias to an interface. And some people even go as far as cloning the loopback interface. So instead of having LO0, you'd have an LO1, and you put all of your IP addresses for your jails on that. They can be either routable, so you can have your jail directly exposed to the internet traffic, or they can be non-routable and use port forwards to be able to forward traffic back and forth between. And then when you set this up, the host and all jails are able to talk to it as if it's another box physically on the LAN. So I'd be able to access, say, the database server that's running in one of the jails through the TCP connection. If you're going to compare a jail to a traditional hypervisor, though, they're a lightweight alternative to things like Beehive, which is FreeBSD's virtual machine tool, QEMU and KVM, VirtualBox, VMware, and things like that. Shares the kernel and resources between the host and jails through virtualization, but it's also able to mimic older versions of the FreeBSD kernel. Because one thing FreeBSD does that Linux doesn't is they actually will change their build interface between major versions. So if you wrote a system call for FreeBSD and then later realized you made a mistake, and instead of that function taking 2 arguments, it needs to take 3, in Linux world, you're just kind of out of luck. You have to write a whole new system call that takes the 3 arguments and then turn the old one into a wrapper to that one. Whereas in the BSD worlds, in the major updates, you can fix that. And so the Jails tool is able to mimic older versions of the kernel. So you can be sitting on a 11.2 host and be able to run a jail that's running FreeBSD 8 something. On top of being able to run just FreeBSD, old and current versions, you were able to run Debian Squeeze as long as the GNU KFreeBSD kernel and CentOS 5. They haven't bothered updating it because it wasn't a thing a lot of people used a lot, and it was a lot of extra work on developers to maintain the support for those. But it was done. Whereas in Docker, you're limited to Linux distributions. So comparing Jails to Linux containers, Jails was built up front as a production security tool, whereas Docker and Linux Container Engine was more built with system admins and developers in mind at first, and then kind of shoehorned into the production role. Jails has been around for 18 years now, giving them a lot of time to fix bugs and security issues, and not only the Jails implementation, but also the FreeBSD system. And one big difference is in the Linux Container Engine, your main point of security is your containers have to run as an unprivileged user. That way, if someone breaks out of that container, they can only have the level of access to the system that the user running it does. Typically, you would not want this user to have the ability to run sudo or su or anything like that to further limit it, whereas Jails was built to only be ran by privileged users. And by this model, there's only one confirmed way to break out of a jail, and that involves both the host and the jail system being compromised together, and then you can try and circumvent that the protection there. But if you securely lock down the host, it's very hard to do. So there's a couple of front ends for Jails. There's the official JLS and JExec commands. The JLS lists all jails, whether they're running or not, so you can see what you have created, whereas JExec is designed to create and manipulate the jail. Downfall to these implementations, though, is it heavily relied on the environment variables for configuration, and it was tied directly into the init system. Some people had problems with this implementation, so we saw things like easy jails come around. This is a collection of shell scripts that makes working with jails easier. It breaks out the configuration from environment variables into configuration files, and it also breaks it out of the init, managing it through the init system. But it has a daemon where you can tell it start these jails when the system starts. So as easy jails grew, though, it started to lose its namesake of being easy, and that's when IOCage came around. IOCage has 2 main versions right now. There's a legacy version that's in shell scripts, and then there's a beta that's written in Python 3. It supports having the configuration and the management outside the init system environment variables, just like EasyJails does. The legacy actually put the configuration files into ZFS properties. So your configuration for the jail was then made part of the file system itself. And whereas the beta version is just using a JSON file now for consistency and making it easier, because the legacy version broke if you did a ZFS send and receive to move your data set from one server to another. Those properties didn't get copied over because they were unknown to the ZFS tool. So this creates a ZFS dataset per jail, which breaks IO cage's compatibility with UFS too. It hard depends on you using ZFS file system. And yeah, as I said, the configuration using datasets versus JSON files. Whereas if you look at the Linux container front ends, LXC is the official one developed by Canonical. It was very, very difficult to work with. You'd have to use these long strings of incantations to be able to get it to function. And the only real security measure was running it as an unprivileged user, which in the Linux world, if you're okay with that, make sure your user is set up perfectly to where it can't get elevated privileges. It's not so bad, but it is a problem. Then Docker came around as one of the bigger and more popular front ends to LXC. It made working with LXC a lot easier, but as Docker grew, they got to the point to where that wasn't ideal, that wasn't good enough for them. So then they rewrote and became their own interface to the jail system call, or the container system calls and everything. And then another popular one is Kubernetes, developed by Google. So it's a Docker-like front end. It's able to read Docker files. It's able to use Docker images and things like that. But it's not actually using Docker under the hood. Now to get into the more obscure ones, there's things like libvirt, which is a multi-hypervisor front end. It supports things like running a virtual machine using KVM or VirtualBox or Beehive, things like that. But it can also use Linux containers. The problem with that is it's a little bit more complicated to get set up than using say, Docker. But if you're already running virtual machines with libvirt, it makes sense to use that. And then there's everybody's favorite, systemd. Systemd has nspawn, which is able to manipulate and manage containers as well. It was also developed as an easier front end to LXC and libvirt. It's a lot simpler to configure, a lot simpler to set up. And you fall back to the same problem that JExec did, where you're heavily tied into the init system at that point, though. So let's do a little bit to show some of jails. Everybody able to read or see the prompts? So on this server, I have one jail already running. So there you can see the host name of the jail, which is Hugo. Let me highlight here. Oh, wrong one. So you have that. You can see the current state, whether it's running or if it's off. You can see the FreeBSD version that it's running and its IP address. So let's just go ahead and create a new jail real quick. And I have to use sudo because I'm not roots, but you have to be to do this. So when you create it, you give it a host name. We'll say chdev in this case, and you have to specify the release. We'll do 11.2 since that's the most recent, and you give it your IP address. So the definition for this is you tell it the interface. So loopback 1, and the IP address you want it to have. And the subnet mask of 24. So we have our new jail. And we can confirm that with doing a list. We have a CHROOT jail, current state's down, it's 11.2, and it has an IP address that ends in .3. Now, for audience who uses Docker or Linux container, what is the smallest image, base image you've seen? No idea? All right, well, just to show, I think a couple months back, there was one where it had 24 megs, I think was base image, using one of the smaller distros designed for Docker. But if we show the file size here, this is 280 kilobytes for the jail that we just created. And to break down some of these other fields, we have the CRT here is the compression ratio. So this jail that's been running for a while has almost a 3 times compression ratio going on, whereas our new jail has none. And then these two are your quotas. So you have resource and disk space quota. I don't have any configured here. The size of the image and the disk space available within the pool. So if we were to run our jail, so let's start this. So our jail is running. We can see the disk space will change a little bit since it wrote things to the logs and everything, but we now have a compression ratio of 1.05. It's just because ZFS natively will compress anything written to it. But we can access this now. So if we do an iocage console and CHROOT, we are now inside our new jail. So I went from being a normal user on the host system to now being root in this jail here. And we have a full file system like you would expect from a system. So let's say we did that in error. We wanted a few things installed by default. So let me go ahead and get rid of this. So we'll stop it. And then we can destroy it. It's going to want me to confirm. And when you destroy a jail, you not only destroy the jail itself, but you also destroy any snapshots you have of it. So it's be aware of that. But let's say we wanted to install Nginx, Tmux, and Vim console. So you define a JSON file with a field of pkgs that's just an array of any packages you want installed. And then you can do your create command with one additional flag. Yeah. So you can say pkg list and then our JSON file and then run it. And it's going to test whether DNSSEC is set up and a few other things, and then get to installing the packages. So this will take a little bit longer than the first one. We have Nginx and Tmux and now Vim. So if we were to go ahead and start this now, okay. So to prove that we have stuff installed, we'll end it real quick. So, yeah, we have a working Tmux, and we have a working Vim. But let's go ahead and start Nginx. Now, for those unfamiliar, the init system and management system for FreeBSD is called service. So it's service, the daemon you're wanting to run, and you give it a command. If you don't have it set up to be enabled in a specific file, the RC file, then you have to tell it one start, because it's going to look in here and say, well, you didn't tell me the service is supposed to be running at boot, so I'm not going to start it. But if you do one start, it will. So our Nginx is running. I'm going to hop out to the host real quick to show one thing. So since these are using non-routable IP addresses, I have a port forward set up in my pfSense, the firewall. So any traffic that is going to come in from the external interface on port 8080 will be redirected to my jail at port 80. And I have one at 2222 that goes to port 22, because I did a similar talk to this for another. And I've had someone SSH in, completely destroy the jail. I just went in, rolled it back to a snapshot. Everything came back up within a minute. So we can actually see if Nginx is running real quick. If we open a new browser and go to, a little hard to read, port 8080. Now to prove that I'm not tricking, we'll go ahead and tell that jail to stop Nginx. It'd help if I type the host name right. So our Nginx should be stopped, and we can confirm if we reload. This should just, yep, it went back to there. Try going to 8080 again with no HTTPS. That didn't really up what I needed to up. Yep, I missed the colon. Using that small monitor is hard, and using this is tedious. Yeah, see, it's just going to keep sending me back because there's no one answering at the 8080 address. Let's see. Since it's been running a while, our disk space would still be small, but we'll have a little bit more usage. But yeah, with a 1.5 compression ratio, it's about 74.7 megs. Still not too bad. But, and so, yeah, I don't think we be able to do the showing off the recovery, but you can snapshot just as easily. So you just do a snapshot and shot F, the name of the jail, and it will tell you it's created. So. Only the port 80 and 22 because of the pfSense redirect. Any other port wouldn't go anywhere except to be handled by the host if the firewall allows it.
Okay, so host, any port.
Yeah, if I'm on the host, I can access any port within the jail. So if I was running, say, database servers such as Maria or MySQL or Postgres or anything like that, I'd be able to do a TCP connection to the database through the correct port for that database. If I was to start up Apache again, I'd be able to pull that Nginx default page from the host using a text-based web browser or through curl or something. I can actually start it back up again, because that's easy enough to show. So if I would say, fetch is a FreeBSD tool similar to wget, but if I say, address wrong or something. If you set up zeroconf, you could use the host name, yes. There we go. Fetch didn't like it, but Carl did. So that's just the Nginx default page. So another thing is as I said, the host can access the jail and they can see it. So if you do a PS, you'll notice some processes here have end in a, on the column tab here, they'll have a J. That indicates that that process there is running within the jail. But if we go into one of them, and run that same PS, AXF command, we just see the processes running there. And you can even manipulate the file system if you are root. So we can say, so we can create a file within there. If I had the path right, I think. Oh, yep, that's why jails, it's plural. I don't do this often. So we'll create a file within the root home directory called delete me. And if we go back in there, there'll be a file there's a delete me file. But the jail can't do that in reverse, so the jail can't access the host, nor can this jail do the same thing to another jail. So, and that is about all I have. If there's any questions.
So if you wanted to, say, take jails into deployment or for distribution, like would you start with a snapshot, or how would you distribute it?
That's a good question. So if you had a jail that you've had configured and you wanted to move it from one box to a production environment, you can do it with a snapshot. So you can do a ZFS send of the data set and receive it on your production. And then you just have to do if you do it that way though, you manually have to move the configuration over. IOCage and Easy Jails has a ability to package it up though. So, so with IOCage, you can do an export, I think is what they call it. Yeah, export, you can do an export. This will dump the configuration and the data set into an image that you can then just copy over and then do an IOCage import. And that handles creating the jail, setting up the configuration, and everything. So it's similar to having a Docker image that you pulled from Docker Hub. Does that answer your question? Yep. Any others? Any heckling? FreeBSD and the guy in the room. Someone has to have something.
Let's give Adam a round of applause. and we'll see you next week.